So the next couple of minutes, I want to go over some terminology, some concept of AI, so you guys understand. When you read the news, read the textbook, you understand some basic concept of the AI and the machine learning. So the first thing I want to talk about is what is transformer. So you guys see, transformer. Everyone talking about transformer is dominant right now. Every machine learning AI large language model, we use transformer. What does transformer mean? So in order to understand the transformer, you have to understand what is encoding, what is decoding, what is the transformer. So you can see that the encoding model, Google BERT, is the encoding model. GPT is the decoding model, and then we have the transformer, and we have the model of that. So let's understand the idea of the transformer. So let's say you turn into English into the machine language. So this one is called encoding. It's called encoder. And then if you make a machine language into the French, that's called a decoder. So if you add the encoder and decoder together, it's called a transformer. So you can see that if you change the English to this like a machine vectors, and then that's an encoder. But if you change the vectors into the French, that's a decoder. So the translation is a very typical example of transformer. So you translate to machine language, and then you make a machine language transfer back to human language. So this is transformer. And the transformer so right now the common sense so far, common sense is any sequential data, transformer will do very good job. So what do you mean by sequential data? I think I explained last time. When the data has the sequence, for example, text data has sequence, image data has sequence, time series data has sequence. Any sequential data, the transformer performance is just dominant, right? That's if you see your data pattern has the sequence, either time series or language, right? Language has a sequence, right? Or I say things has a sequence. So any sequential data transformer which is dominant, So and then the Google BERT. So I have other slides talking about the Google BERT. I don't want to repeat here. You guys can read the Google BERT here. Just refer to my another videos, to my radios. What is the Google BERT? I want to talk about some philosophy of machine learning. So some of the stuff. So one is initialization. So what does initialization means is so basically the human has initialization, the machine has initialization. So what does the initialization mean is, I told you guys, you can train machine, right? So let's say go back to the earlier example, the machine can do the exams and then to learn from the pattern and do better for the future exams. That's an example of the training process. But how does machine do the first exam? Because the first exam, machine has no knowledge. How machine do the first exam? That's a practice exam. So let's go back. How human do the first exam? The way human do exams is you take the course, right? You take the course, you understand what's going on, and you take the first practice exam, and you learn what is wrong, and you correct the mistake, you take the exam again. That's human, right? Human initialization is you study, and then you take the first exam. So what a machine do is, when machine take the first exam, they randomly choose answer. And then once they randomly choose answer, they will check which answer is wrong, which answer is correct. And then they learn from that mistake and then do the iteration again and again and again. That's an interesting concept, you guys think? Because for human, what you do is you study and you take the first exam. But machine what do is it just randomly choose. After random choose, it's initialization. And then they learn from the mistakes, from their choice. And then from the 2,000, 3,000 iteration, machine will get right. Right? Machine will get right. So for the randomization, this is a very interesting question. When machine randomly choose answers, let's say the exams are all multiple choice questions. Is it better for machine to all choose A or randomly choose A, B, C, D? Let's say all the multiple choice has A, B, C, D. Which one machine will learn quicker? Is it quicker for machine to choose all A's and then to check mistake, or the machine to randomly choose A, B, C, D and then check mistakes? Eventually, the machine will learn quicker if they randomly choose. Because when they randomly choose the solution, they will learn from each mistakes, right? This is so you can see that. So basically, it's an interesting concept. So what machine will do is when machine do the exam, they just randomly do that, and when human do this, human will study and take it. So basically, random answer will be closer to the truth and then faster compared just to do a constant answer, And then, sometimes, I do a lot of machine learning. Sometimes I think like a machine as well. Sometimes I ask myself, like, sometimes like a human, we just hesitate. It's like, oh, we have to get ready before we take the first exam. Let's learn from machine. Let's just do it. Let's just do it. If it's wrong, let's do it a second time, right? I just feel sometimes the more I do machine learning, I start to think like a machine. I look at some of my friends, I look at some of my colleagues, they're just hesitating. No. It's not ready. I don't want to do the first one. I don't want to do the first one. Just do it. If it's wrong, okay, I learned a mistake. I just do the iteration. From the iteration, you can get things right. So this is one philosophy I learned from machine is just do it. Just do it. You never get things right. You just do it, learn from mistake. And that's what machine is doing. They randomly choose. What we do is better than random, right? So this is first thing. You can see that this graph explains why the random answer is better than the constant answer for the initialization. I will leave questions for later on once I finish recording. So the forward and backwards propagation. So this is also basic concept of machine learning. The machine has the forward learning and the backward learning, backward propagation. So what does that mean? So I give you two examples. So for the first example, you see what the human learning the exams. The human will learn math first, and then run the regressions to learn back. So human will learn the foundation and do the math. So what machine will do? Machine will just do the question, and if something is wrong, they will learn what's wrong with this. So machine will do the hands-on exam first, and then if they think they will learn math, they will learn math. If they think they will learn physics, they will learn physics. So you see, this is different learning. So this learning is called the forward learning. It's called the backward learning. Backward learning means you can see the graph here. You can the y1, y2, ym. So this is the solution. This is the exams. So machine will take the exam first, and then they will learn the knowledge most relevant to the solution, and then the knowledge most relevant to the green parts. And so you see what machine is doing. They will learn the stuff most relevant to the exam, and it is back propagation. So what human do? Human will learn math first and build the foundation, and going to take the exam. So you can see that different learning process, right? So you can see that what a human do is human learn the foundation, and then after foundation, then take the exam. So what machine doing is machine will take the exam, and then see, oh, I need to do math. Oh, I need to do physics. They will focus on the question, and then to back learning what's the relevant knowledge from the questions. So what is right, what is wrong? I don't have the answer for you. I don't know which is wrong, which is correct. Do you want to do the forward propagation, or do you want to do the back propagation? I don't know which is wrong, which is correct. But I can tell you, over the last 20 years, the knowledge production has exploded. So many knowledge. If I was born 100 years ago, I definitely do the forward propagation, because I will only learn the foundation. I want to get comprehensive knowledge, and I do the exams. But in the past 15 years, like 20 years, there's so many knowledges. It's difficult to master all this kind of foundation knowledge. Sometimes we have to learn from machine. You have to focus on the question first, and you do the back propagation to learn what's relevant knowledge. So you can see the time has changed, right? If I was born 50 years ago, I will do the forward propagation. I will learn the foundation first, and then I will do the questions. But now, because of the massive production of knowledge, it's so difficult for human to get all the foundation. So maybe we have to borrow from the philosophy of machine. You have to focus on the question and learn the most relevant knowledge, like back propagation, right? That's still, I'm saying, I don't know which one is correct, which is wrong, but I just feel the massive production of the knowledge, maybe you have to learn the philosophy of machine. Like I told you guys, the more I do machine learning, the more I do AI, I think like a machine right now. So you can see this is what the philosophy I borrowed from machine. And I also want you guys to look at what's the concept of the emerging ability. That's very interesting stuff. So what is emerging ability is the large language model can do general stuff. They can also do special stuff. So emerging ability means the AI can do things they were not trained before. Is that scary? So let's say if you train AI accounting, if you train AI finance, AI can do accounting, can do finance. That's intuitive, right? But you never train AI some subject, but AI can just do the subject for you. That's called emergent ability. That's called emergent ability. Is that scary? Because, if you train AI can do stuff, that's easy, right? You can control. But AI can do things you never trained AI before. That's very scary, right? That's emergent ability. So why this is emergent ability happens? So this emergent ability happens because sometimes when AI learning accounting, learning finance, they from learning accounting and finance, they can understanding this accounting finance, they can combine the two major together to answer answer the discipline they never trained before. So one example you guys can image is, think about it. You can train GPT about econ. You can also train GPT about statistics. Once you train the GPT about two majors, and then GPT can easily answer questions about econometrics. Even if you never train anything about econometrics, GPT can answer econometrics questions if you train GPT well about economics and statistics. So you can see that. So what is emergent ability means? If you give a new task to GPT, GPT can break down the new task into subtasks. And if all the subtasks belongs to the previous training process, then GPT can finish the subtask and do the new job for you. Does it make sense? So for example, in the earlier example, why GPT can do econometrics? Because GPT can break down the econometrics into econ and statistics. Once they break down the econ and statistics, they can answer the questions about the econ, they can answer questions about econometrics, about statistics, and they can combine together to answer questions about econometrics. That's how emergent ability comes in. That's emerging comes in. So you guys, I hope you guys get the concept. The concept is while we never trained GPT about econometrics, but the GPT can break down econometrics into econ task and the statistics task. They can break down. And we trained GPT about econ and statistics. So they can answer the questions about econ, answer questions about statistics. And GPT combine the two tasks together. And once they combine them together, they can answer econometrics questions. That's called emergent ability. It's scaring. The reason is scaring because we never trained GPT about econometrics, and GPT can answer that for us. It's out of our human control. But remember, this depends on what? Depends if the new task is highly correlated with the trained task, the emerging ability is very high. But if the new task, let's say is like a theoretical physics, if you give the GPT theoretical physics, the GPT cannot do the job because even they break down the physics, they can never link the subtask with their trained task. You cannot build a link, and then GPT cannot have the emergent ability. So the emergent ability depends on how well the GPT can break down the new task into the pre-trained task. I hope that makes sense to you. So basically, if the new task can be break down into different tasks, subtasks, and the subtask is highly related to trained task, then GPT have the emergent ability. However, if the new task is about physics, have nothing to do, even you break down the physics, you can never break down the physics into something related to accounting and finance, GPT will do bad job because the new task is very remote to the trained task. If that's the case, GPT has not an emergent ability. So that give us a lot of comfortability, right? So it looks like a GPT emergent ability is under our control, right? So because if the new task is related to the trained task, they have the emergent ability. Otherwise, it doesn't have. It seems like we have a control, but think about it. Before we only trained GPT 1 million tasks. Now we are training GPT 10 billion or billion tasks. The more we train GPT about this task, the emergent ability of GPT will become higher and higher. Eventually, anything will be related to the new task. Does it make sense to you? So right now, the GPT emergent ability is very small because we only train GPT only about 1 million tasks. But in the future, we are going to train GPT 1 billion or 1 billion tasks. If GPT has trained of billion tasks, the emergent ability will be very, very strong because any new task can be break down into the trained task. So that's scary. I hope it makes sense to you guys. So right now we are good because the training task is small. We only train the GPT a very small number of the task, but when the GPT will train at a minimum task, any new task can be broken down into the training task, and the emerging ability will become massive. At that time, it's very scary.